Okay, so the pieces first. To build distributed to build a distributed system which stores and serves files on demand, typically needs to have a set of persistent data stores. So a bunch of databases like SQLite floating around. I mean, it does help to have like some. For example, if you have like SQLite, right? It does give a lot of guarantees, so that's very welcome. But I think the whole point of what we are doing is not to rely on this, right? It's literally just write. So a coordinating unit and a user-facing dumb client. Data node. Data nodes in this system are just holding the data, and when provided with an address, can write to or read data from that address. So it just holds something provided with an address.
Okay, so this is actually the way we do the persistencies, right?
Yes, apparently it seems to
So
be the case.
apparently, that we're gonna have some nodes that are only storage, and apparently there's something the name node, which does whatever, coordinating unit of the entire system.
Well, bear in mind here that they're calling node, but I don't think these things need to be like microservices, for example.
They don't need to be in separate machines necessarily. They may
Exactly.
potentially
So,
be, but not necessarily.
like, this separation is more logical, it seems to me, than
Sure,
physical.
sure.
The data nodes deal with chunks of data, which, when aggregated by someone else, makes sense. Okay? So it's just splitting a
So it's
video.
exactly what we discussed. The server Canteen will never know what the heck makes sense. Like it's just a bunch of bits as far as Canteen can tell.
Ideally, which is like what Kafka does
Yeah.
monotonically, increasing topics. Uh, partitions inside the topics. Ideally, the number of data nodes should be greater than one for it to be distributed. Okay, that makes sense.
That was funny.
Also, if it is not necessary, it is not necessary that a single data node would contain every chunk on a particular file. Right, that's a given.
I don't know
So
if we should
name
do that
node.
though. Like, are we gonna split files? I thought about splitting like,
That's the whole point of having it distributed, right? You don't know where it is. It just
uh,
goes anywhere.
uh, well, I was more no, I understood it now. That's true. Continue.
So the point is you add a row, like think of the database scenario. You add a row and then you convert to bits and then it's the row for the person.ndf file. Then it goes to this data node, then the next row goes to the other data
Yeah,
node,
I
and
was kind
then
of thinking that we should, like, as a first draft, we should try to maintain a complete file per in one node, because if we don't, we're gonna have to keep track of like I have IDs from 70,000 to 90,000, and then there's a huge gap that is not in here, is in another guy, but I do have 12,000 onwards.
well,
Somebody's
that's
gonna
the
have to
whole point.
keep that thing.
Yes, that's the whole point of doing
This
this.
this reminds me of torrents actually.
Oh yes, that's true. The torrent protocol, indeed. Okay, let's continue here. The name node is ideally a singular central coordinating unit of the entire system. It's like a DNS, I suppose.
Hmm.
Its responsibilities start from record keeping, of which all data nodes are available and healthy, and helping the client decide to all where all to put the chunks. This text is kind of weird.
Weird
All,
AF.
yes, the chunks for an incoming file, and where all to
Fetch the
fetch the
chunks
chunks
from
from the
requested
requested
file.
file. The name node also knows what is the chunk size, so term the block size later, and how many copies of data to keep, so replication factor. The name node is the know-it-all guy of the system, and therefore make its
It's
death
that.
fatal for the system.
Yeah, that eats is not
Therefore, we
correct.
must have a backup name node called the secondary name node, to which the name node is flushing all its metadata periodically. So I see. So in the same fashion as the GFS, there is one master node that that is like the bookkeeper, right? It
Yeah,
keeps
pretty much.
knowledge of all of this
That's
garbage.
gonna be the name actually, bookkeeper.
Well, these names are very odd, I would say. But okay, so there's the bookkeeper, and it keeps track of all these things, but it always has to flush the data and make sure. I think it should be one of his duties. Should make sure that at least another node has. So the ideal scenario would be that everybody has the same data all the time, right?
Yeah,
But that's nearly impossible,
that's
right?
nearly impossible.
So the best we can do is like to make some guarantees that at least this n number of nodes, that n is less than the number of nodes, is strictly less than the number of nodes, has this. So it has the guarantee of at least perform a write, right?
I have a question though. If how many name nodes are we gonna have? Because I was thinking that every single node should be a name node.
Yes, that's what I assumed. In his scenario here, there's like one or another,
Yeah,
or
the problem is
probably
that
one node that gets promoted to a name node. I don't know, something like this.
Marinho?
yeah, the problem is that if this guy goes down and there's only one of it, and the entire system goes down, that's kind of bad for a distributed system.
Not only that, I was more thinking about the routing because if we only have a single bookkeeper, every single route needs to pass through that node, and maybe that's really really far, right? Like geographically speaking, like in terms of the computers. So
That could
Yeah.
maybe
be replicated, so you could have many of these guys, but there will be latency now to coordinate the messages between them anyway.
sure.
So I don't think there is an escape on that. Okay, let's continue here and then we think about this. So client does all the talking. Upon the client getting a request from the user interface, its job. Man, this text is terribly grammatically incorrect.
Yeah, that those two eats there, they are wrong.
Yes, but well, I appreciate the guy writing this. It's just
Sure.
its job is to first contact the name node for all the meta information. If it is a file put request, name node helps it by providing where all to keep the chunks in, the endpoints of the data nodes, and the target directory path within them. If it is a file get request, the name node helps it by providing the intrinsic details of where exactly to obtain the chunks from. So it's basically the a resolution process, right? So it does some communication with the name thingy, and then that thing tells us, okay, so this guy here, this guy should have the data, and then like it just organizes a request that picks all these chunks from. I mean, what's the point of this then? Uh,
I think the point is like I think the way that it's being described, you as a client, you talk to the name node. The name node will return you coordinates of how to retrieve the information that you're looking for, and then the client does a second request using that information.
yes, but that like first of all, that's not transactional. First, so assuming that you could modify the data, right? In meanwhile, then the data would be old. So
Yes.
you have dirty reads there,
Yes.
Uh,
unless
you know,
you give some timestamp of the data. So like you version with a tree, like for example Merkle tree, that I'll call now by the way miracle tree. So if we have something
I
like
like that.
that, then we pick a specific hash of all the data on the closure of this data at this point, right? So then things should make sense. So even if it gets modified after, it shouldn't matter. So I think that would solve it. But still, I think this architecture, it's good for educational value to understand like how to communicate with other things, but it's kind of like missing the point of of being distributed to begin with, right?
I agree. I agree.
Yeah,
It's just separating things in nodes, but well, they are behaving like they would on my machine. So what's the point?
Yeah. So
Okay,
maybe we
so
should
what should we do?
change this stuff
Let me
ourselves.
stop here.
I think we should. Uh, the idea of
Let me
having the
open.
roles, right? So we have a data node and a name node. Forget the name node. I'm going to call it a bookkeeper node. The data node can have bookkeeping capabilities because those are just only rows, right? They don't need to be necessarily separate. And then my idea was that when a node receives a request and identifies that it doesn't have the data that the payload is looking for, it talks to the other nodes in some manner to retrieve, and then at some point it's going to retrieve the data, right?
I
At
just discovered that IPFS uses the Merkle trees.
awesome. So maybe we should
So yeah,
start by saying what should a node have in terms of the implementation details.
so let's think of the actions, right? I think that's better. So let me share my Emacs here for a second. Can you guys see?
And yes.
yes, I can.
So let's start with the general overview. So actions that we should support, right? Write, read.
Those are
What goes in
actions
the
that
right?
can be triggered by the client.
Yes.
Okay.
So let me specify client there.
Yeah.
So the client can say, okay, I want to write this piece of data. So it has a chunk. It has a chunk. Oh, it has a this data in binary, whatever.
Okay, so
So with
I
that,
three things I think it should send as the right. The name of the file, the payload, and the position. That's it.
and the position.
Yeah,
Why
because
the position?
Canteen doesn't have a notion of chunks or IDs. It only knows how to pick a file descriptor, travel the file to the position that you
Well,
said, and write the data down.
like I'm thinking differently. Like I'm thinking of because you're thinking of like the me writing to a disk and it writing sequentially, right?
Well,
Uh,
yes.
but if we are writing something like, for example, with a timestamp, I don't know, some key, whatever, and the data, that's just like this is the storage. So you could just write in a sequence, like that's what Kafka does, right?
But are we gonna do only like an append only system?
What? I mean, you can
That's
remove,
actually,
but you need to know the key.
Marinho?
yeah, I'm thinking that doing append only is actually probably easier in a distributed system because changing things is difficult because then you have to worry about propagating the change.
Yeah. And then things may be old and all of that.
Oh, yeah, you need to propagate that shit. I forgot about that.
So let's think small here.
Okay, but I have a comment about the key thing that Makita said. If we put a notion of a key, then Canteen needs to have some logic. It's not only a writing machine and
Yeah, it
routing.
could be a SHA. It doesn't matter. Like
Could be a
SHA
SHA.
of this is the key, whatever, and then it stores there. Because if the data collides, right? Then let's say, for example, you say file. Uh, I'll put the record you were saying here. So file
File,
name.
yes.
Man, what is wrong with me? So it's a string. So file name, and then the other is the data.
Payload, the data, yes.
I'll put payload, and it's bytes.
Bytes.
And what else?
I was thinking about
I think
having position. So then you open the
okay.
file
Let's
in this
ignore the
position
position
and
for
go.
now
Okay.
because position is just something that makes sense if you have a hierarchical file system. Let's try to root out that idea.
What do you mean by hierarchical though?
Like writing bytes so after bytes, like one, two, three, like positions in a file, like sequentially.
Ah, okay, yes.
All imagine all of this is floating in the air, like something like this.
Mm-hmm.
So if we have just this, I think that's all we need because then we are saying write for me in a virtual file this guy here. So now this file name has this guy. So we could even do further as to say an operation, right? So something like override, like operation, and then it's an enum, like operation.
Mm-hmm. Mm-hmm.
Ah, sorry, I
Yeah, that's
haven't.
gonna be an EDT, like a sum type, right?
And then the enum would be something like write, append, uh, well,
Override.
read, but read doesn't really make much sense here.
Yeah, yeah.
But anyway, like whatever for this example, I mean. But okay, and then if you get something like this, like append, then it just appends, but then it has to propagate the change and all that stuff.
Okay, so I have a
But I'm
question.
thinking,
If we're going, let's suppose that a client
hmm,
wants to do an update. How does that work?
let's think
You
first of
write
how we are gonna keep track of this garbage here, and then I think we are gonna go to that answer. Because think of this: for me to store this thing somehow in a bunch of tuples, right? Key data. That means that you need to have somebody like the bookkeeper that knows where this data is.
Yes, that's the logic that I was
So,
talking about before.
but but then let's think. The, having one bookkeeper is kind of bad because if the bookkeeper dies, well, it
Nobody
takes
knows
the
shit.
it takes the books with it, right? So it's like the Library of Alexandria.
That's good.
Uh, so
the
what else
bookkeeper
we
should be
could?
called Alex.
Sorry, what, Maria?
The bookkeeper is named Alex.
Yeah.
Alex Serapion.
Ah,
No,
Uh,
I'm
it's
liking it.
because it's the Library of Alexandria, so the bookkeeper is Alex.
Yeah.
Alex. Okay, so then we should think instead of just keeping one guy, we should think of how to store things from the bookkeeper. How to make the bookkeeper propagate and make sure it is propagating to at least another guy. So at least one. I think that should be the thinking. Not to synchronize across everybody, but at least synchronize with one of them.
Um,
How do we do that?
I think there's oh man, this is gonna require versioning. I'm sad, but okay. So
Like,
I was more thinking,
isn't that what Raft does?
yeah, I think yeah.
And you're gonna implement that.
Okay, so I
You're
was more
crazy.
thinking, the bookkeeper keeps track if like, oh, did I make a change in my book that I saved stuff. If the answer is
Hmm.
yes, then it triggers a request to the other bookkeeper to update with the diff of. We can even use git diff to do that. That's kind of crazy, but okay. Uh, and then it sends
Wait,
that.
man. Again, you're thinking of a file because think of this. It's simpler because it doesn't matter where this is written.
No, no, I'm not talking about the location. I'm just talking about the key and the data, right? So we have 5 entries right now in your example. Let's suppose that you add a sixth one, right? So this
Okay.
would mean that the book is needs to my book is more up to date than somebody else's.
Uh huh.
Okay, so I'm that there will be some process that like something will understand that oh my book changed, so I need to talk to the other guy so he can change his book as well, and then we send the new entry, the key data pair, to the other node, and it updates its book.
But here's what I'm saying. This could be SQLite.
Oh, so the book is also in the database.
No, no, like, well, not the book, right? The book could be as well, but I'm saying maybe that removes some of the fun out of it. But uh, the nodes, like the data nodes, instead of writing to a disk, they just write to SQLite locally. You're technically writing to a file, but then you have guarantees that you are writing, right? That's one. You have guarantees that you don't care where the data is at on SQLite, and
Hmm.
it's all just key storage.
And then you will do an insert to your friend. Is that what you're suggesting?
Yeah, you just propagate the
Ah,
difference, right? Which is the insert.
ah. Okay, I think that can work, Marin.
And then I think we could do something smart with like, well, we could propagate the whole SQLite file, right? But
No, but that's gonna
I think
get out of hand fast. We should not do that.
yes. Oh well, we are gonna have propagate commands either way, right?
Sure, sure.
Hmm.
Marin, do you think this has
Maybe
potential?
I think it does.
Okay,
maybe we
the
don't
question
need
of an update
SQLite.
is my
What I
question.
mean, what I meant with commands is like it's like the inserting tool, right? Insert this thing here.
Mm-hmm.
Um, I'm thinking here because when the client says write this data to me, and then it says this, right? File name, operation, and a payload. We don't actually want this data everywhere.
We don't.
Do we want it replicated across every damn node?
I think not the data, but the bookkeeping, yes.
No, man, we need the data because if this node dies, then there goes the data, right?
Well,
So to
let's
to
maybe
have
rephrase it. I think we want to replicate the data a little bit, but if you have 500 nodes, not all 500 of them need the data. Somewhere else,
why not?
someone else needs the data because that's gonna put a lot of overload in the network. No, because these guys are already exchanging messages because of bookkeeping. We're gonna also make all of them communicate because they need
Oh,
to update the
what I'm saying
databases.
is that bookkeeping could route to a single one, and then this guy broadcasts the thing to the others.
Route to a so only one bookkeeper?
Like bookkeeper says, you're responsible to store this thing first and broadcast, and then this thing stores, and then it says, "Hey guys, I got this new data," and then everyone has to resolve with this one.
Mm-hmm. Mm-hmm. Okay, I see. I
But
see.
I'm thinking, what's the benefit of doing that compared to just making the bookkeeper say, "Hey everybody, write this data here now," and then everybody has to comply with that.
No, the only difference is the overload because if you do the thing that you just said, you're gonna basically like the network will have to handle everybody communicating that shit.
Oh, but both ways I do. There's no free lunch.
Well, in the other way, there's a little bit of a delta, right? Because the bookkeeper talks to one guy and then the other guy broadcasts. So there's a delta time difference in there. But you are right. There's no free lunch,
Yeah, man, this is
and this is fine. This sounds fine.
any thoughts, Marinho? Fernando?
Um,
Oh no.
Marin.
I'm thinking technically, yeah, we do want the data to be replicated. It doesn't necessarily have to be everywhere. Um, but yeah, we do need to replicate it somehow. And I don't know. It's not obvious to me how to do this in a way that's efficient enough, I guess.
I think we should not care that outstandingly about efficiency right now, about performance, because this is a very big area in CS. I think it's fine, but I wonder how the heck we're gonna solve the update problem, Magit.
Oh, Raft.
Raft.
Yeah, we need consensus, right, with the changes.
That doesn't answer the question. I'm gonna rephrase the question. I have some data, right? I'm a client. I have some data, and I want this data is already like the primary key of this guy is already written in the database,
Right.
but I need to update this shit. I don't have a position. I only have the file name and the bytes. How will Canteen know first where the fuck is this data at? And second, how will it know that how many in the file in whatever node where
Wait,
to put this?
let's go over the first question first. So say it again, like one more
Sure.
time.
So I have some data that I need to update from an already existent.
Right. So it is somewhere in the system. You don't know where it is.
Yeah, I don't know where it is. I thought about the nodes getting like answering the client with the hash, but I don't think that's a good idea.
Well, the way I see, if we gotta update something, then you're gonna have a file that you want to access,
Yes.
a payload, and you need some like a seek, right? The position you want. So you would
Exactly.
have to know the key. So that's why you said position in the first place.
Yes. Yes. But then that's the thing. I was thinking about position because then each individual client can calculate the position because they know the chunk size, they know the entity size and all that stuff. So they can do the math, right?
Right.
Um, but yes,
What
we
about the
could like when you ask to write your file name operation payload, the data node or the bookkeeper node, whatever, can give you back the key, right? So then the client knows and is gonna have to save that stuff, right?
yes.
But that's the thing that I didn't want. I didn't want to add
Yes, I don't want to make the
overload
client. Yeah.
because now
And
that
then and it's bad because they're leaking this information
yeah,
to
you
the
were
client.
leaking.
Like the
That
client
that
shouldn't
is
care about
exactly.
this.
Yeah, this is information leaking. But this would be a workaround. But I don't want that because that would force the clients to have two notions of databases. It's the database that I care about my business, and it is the database of keys from my
Let's
distributed
think
system.
of something here. Like let's focus. Let's try to narrow down to our problem, right? So we have rows, and we want to write those rows. So we can generate a every row. It can be append only, right? There's no reason for us to always keep updating, but we need to know that this record is old, and to learn how to ignore this record, right?
Yes.
If we send the record, like we need a key to be able to replace the old record. That
Yes.
doesn't mean we need to delete it like on the same position though.
Mhm. Sure.
We can just append. But if you do that, there would be the bookkeeper would probably have a list of pointers for each data, for each file rather,
I had an
uh,
idea.
containing like
Shit.
saying, okay, first thing of this file is this guy, second thing of this file is this other guy, third thing of this file is this other guy. You see, a list of pointers like that. So it would be like a ginormous hash table
Yeah, if that
with
list of
lists of
pointers was
pointers.
actually a list of if that list of pointers was actually a list of hashes, that's basically a Merkle tree.
Wait, say it again, Marinho. I didn't get it.
If that list of pointers was a tree of hashes, that's basically a Merkle tree.
List of pointers. Hoo-hoo! There we have it. Indeed.
Wait,
Because
I'm gonna
then
have
you
you
are
to repeat,
versioning
Magid.
the data. Like if I thought of doing a hash table, and inside this hash table you would have a list of pointers, right? What Marinho said is uh, instead of this hash table, that's exactly the idea of having a tree for each file
Yeah, no,
because
but
you're
that
versioning the file.
no, yeah, but that doesn't. Maybe I'm too slow today, but I don't get how are we're gonna get to the list of hashes or a tree of hashes from
Okay,
the start.
the list of hashes is because think of this. I'll go back again to the update. So think of this. You have received this record here. Let me actually make an example. So you receive like let's do the car example. Okay, so
Sure.
year like 1999, 98, and then like
Mm,
Subaru.
sure.
Tell me car names. I don't know.
We have many in Racket Tower. Do you remember some of
Actually,
them, Marin?
Not really off the top of my head.
Okay.
so the name of this thing would be cars. Ah,
I
man,
rec-
why am I so bad?
I,
So in
we
our
would.
database, it's NDF, right?
Yeah.
Actually, it should be like this, right? If I want. Whatever. Yeah, as an evil, I did three spaces, not four.
I noticed that.
Okay, so we have this. Think of this. Uh, I don't know.
What are the numbers? The
Uh,
primary key?
oh man. Yeah, like it can be. It doesn't matter, right? Card two, card three.
Hmm.
It's one based.
Of course
Yes,
it is.
this is double evil because I'm literally butchering the syntax at the same time that I start with one and I do three spaces without commas. By the way, this,
Perfect.
this is
Put
almost YAML.
semicolons in there just for lols.
Well, I can put. Nah, I'll not be that.
Look at this. Anyway, go.
Okay, so let's think of this now. The problem here would be so you have on this file this thing's written in a sequence, right? And remember, this file it doesn't necessarily mean that it's actually a physical file, right? It could be like SQL Lite
Sure.
writing stuff locally.
Sure.
So what matters is that we have a access on under this name. We have some sort of access to this from this guy to this guy. It could be a hash table
It
written in
could
the
be.
disk, maybe,
It
but
could be.
could be. Um, okay, so where do we go from this to something else, right? So imagine like this: you would have this piece of data. Okay, let me not do like this. So node A. So imagine a case where you have this. So
Hmm.
node A and node B.
Wait, before we go to multiple nodes, man, I just want to know. I'm gonna let you finish. Go.
Okay, so we have these two. So do you agree that part of the data is here and the rest is here?
Yes.
Like think of it ordered, right? I'll put like one, two, three, just to make it easier.
Sure.
So it's like this.
Sure.
So the order is totally divided across the system, right? And let's suppose even it could be replicated. It doesn't really matter. So it could be like C, and then you have the same thing here again.
Hmm.
So that doesn't really matter. The point is uh, on the bookkeeping.
Alex, right?
I mean, I refuse to name it like a person. I'm sorry.
Come on,
So
dude.
uh,
It's the bookkeeper. It keeps all the scares and frights.
This is a pointer, okay?
Mm-hmm.
No, sorry. Node B. So cars.
Ah, I see. I see.
So where is the file? Well, it could be there. We have many options. Like it could be this
No, no, no.
in a
It needs
sequence.
to know the key though. It needs to know the key because it needs to know where who to ask for later on.
Depends. Wait. So node. That's one scenario I'm thinking. So something like this. This is horrible. Like this. So basically it says, okay, where can I get this file? Well, this file is here.
Shouldn't we have node
These are the
C at some
pointers.
point in there?
Sorry, what?
We have two node Bs.
Oh,
Okay.
so these are like, why is this a list? Because there are two replicated with the
Mm-hmm.
same data.
Sure.
So you would have, okay, sequentially, I have this list of pointers where you can start reading from the beginning to the end. You just go looping through at least one of these through all these pointers, and then you get the data back.
I have a question.
Okay.
Are we gonna use the index? Like, let's suppose that whatever you're writing there, exactly this one, these brackets are composing an array, and the first index will be the list of nodes that have the first one, car
Well,
one.
since everything will be ordered, we can kind of do something like put a point here, like saying one, uh, zero. Actually, well, since I started with one,
No.
so I'll put zero. Okay. So it's like this,
Okay.
and then here it says
Yeah, but you understood what
two.
I said, right? We could use the positions as the index.
Yeah,
We
something
could.
like that.
Okay. Okay. Now here's the question. Here's the question. I want to change the name of the one with the two to car 5, right? And I'm a
Okay,
client. I'm a client.
right. So all you would do is you want to change this record.
Yes.
So let's suppose you went there and then you said, okay, I want to remove it. I want to actually change it, right? So you go here and then you say true R5.
Yeah,
Okay,
no,
it's
but
this.
yeah, no, but here's the
And
problem. This car thing could have multiple fields, right? Many fields because it's a table.
this here.
Yeah.
Right, it doesn't matter,
Yeah.
yes.
So imagine that we
It's a
have like
byte. It's all byte from this
sure,
perspective. It doesn't really
fine.
matter.
No, 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 but here's the thing. From a client's perspective, I know there is a table that is saved in Canteen with 50 columns. I want to change two columns of a specific instance
Oh
of a
wait,
table.
Canteen doesn't know its tables.
No,
It
it
just
doesn't
knows
know.
it's
It doesn't know. I agree. It doesn't know. That's fine. Again, from a client's perspective, I'm talking as a client. So I am here, and we are in a meeting of some sort, and I say, Magetta, we should change instance X column 34 to be this value instead of this value.
right.
And then we're going to have to compose a payload to send to the distributed file system to change it, right?
Yeah, you convert the row to bytes
How
and then you say
are,
update this.
yeah, so then the question is, how are we going to communicate that information if Canteen first doesn't have any notion of the structuring, right? It's just a bunch of bits as far as it is concerned. And how is going to find it? Because we don't know where this file is from a client's perspective, right? We just want to do it. We want to do an update of
Well, it
column.
knows that you want to update the this file. So
Yes,
Canteen can know this.
yes,
It actually it is the only one that knows this, right? So it
yes.
knows this file needs to be updated, and it
Mm-hmm.
has the index, like the key indexing key for this record. So you would say, okay, I want to update the row X in my file. For the DB part, the client, from its perspective, is just is this is all is just one file written in a sequence in the disk. It's like one, two, three, four, five,
Yeah.
everything ordered.
Okay, I'm gonna give you a concrete example because I
So
think I know
this
my.
here is literally the row, the line of the file we are accessing.
Sure, sure. But I'm gonna put an example more concretely for you, okay? Because I don't think my message is going through. I want to do an update where
Mm.
name equals car2, right? So we have 50
So
columns, one of them
you
is
don't
name.
know. Okay, you don't know the the key in this
I
case,
don't know. I don't know the key. I just
right?
want to go through all the files where the column, the name column is a particular value, and I want to
Right,
change the year out of this car. If the
right,
car name is car one, I want to change the year to 1999.
right.
That's the only thing I want to do. How I'm gonna communicate this
So
shit to how will
you,
Canteen
but
discover
if you
this?
read, you read. First of all, this query demands you to read everything. Do you
Yes,
agree?
yes,
Because you're not doing something based on an index,
yes.
right? In this
That's
case, you could
correct.
have an index for that, but
Sure.
then that's
Yeah.
the client's concern.
Yes.
And then you would have to generate a payload, but you do have the physical number of where this thing is in your virtual file.
We
You
do
know this
have.
is record one. You know this is record two.
Uh,
Like you know the order of insertion of these things, don't you?
yes, I guess.
So you can update. You just like this is not this is just a physical thing, right? That's my whole point.
Yeah,
So
yeah, Magetta, but Canteen doesn't know the notion of columns and doesn't know that there are many, these bytes have a meaning,
yes,
right?
this is just bytes. I know this is just one blah blah blah. I know
So
this.
you agree that there needs to be a mapping between the semantics, which is an update from SQL, to a seek to a certain position.
Which we already do.
We do.
Yes. You
I
have to
am.
read things from the file to know where the data is, don't you? To build the index, begin with, or to search.
Yeah, I
You
am
do that.
extremely confused.
Like, don't you need the data? Like, first of all, for you to do an update, don't you need the data first in the database?
Yes.
So you need to know where it is on the disk to get it. You need the offset right now.
Well, we don't have
Like,
offsets. We have hashes that are keys.
okay, I'll describe how mine works, and I suppose that's how Racket Tower also does.
Go.
You have record A, like car one, uh, year 1998, and then you have multiple other records
Mm-hmm.
like car two, car three, and car one again with like 1999. This is 1999. This is 2000.
Sure.
So you have this, and you want to update where car one equals where the name, which is this guy, equals car one.
Yes.
Update where. So I'll just do a dumb thingy. Doesn't need to be correct. Where name, something like this,
That's
right? So
exactly what
you're
I'm talking
performing
about.
whatever. So this is not a key. The key here is actually this guy, the guy,
Sure.
right? For you to update this, you need to load the data in the database in memory,
Yes.
and then when you load it, you have the names of you have the positions of everything.
In Record Tower, we just do the math because we know the entity size,
We'll
but
do the math with what?
we do the math with the schema.
With the offset.
Well, that participates,
You-
yes, but we do the math with the schema.
So you do the math with the size of this entity with the thing, right?
Yes, yes.
So you just don't do the math. You already have the offset for the thing. You need to seek the file to the degree that you can. For example, this guy here in our case in Racket Tower would be 4 times the size of this.
Yeah,
So that's the same thing. You just don't multiply. This is
yeah.
just 4.
It just so we're gonna have to send that in the payload. Is that what you're saying?
Yes, this you have to send. There's no way.
Ah, so there is extra data in the payload.
Yes.
Hmm. Next question. How are we gonna discover? Because this number 4 is because we have all the 4 rows in a single place, right?
Yes.
From the perspective of the client, this is 4. But from the perspective of us, this can be whatever the fuck, right?
Oh, it will be 4 as well, but it don't know where it is, right? It's just somewhere. Like it could be here on node D. I don't know. It could be here.
I I think
And
I'm
then
starting to get the
and then we're
solution.
gonna have something like 4. Actually, let me remove the 0. It's annoying me. So then we have, okay, it's on node D.
Amazing.
So when you're doing an update, the client needs to do the math to discover what is the row number of the record that you want.
So
Mm.
the client right now we do the math because we have to deal with the abstraction of the position in POSIX. This would not change. It just changes the logic that we do that.
Okay, I have the next question, the follow-up question. So let's suppose that I want to update only a single field, right, of my row. Okay. So you know it's the
You
fourth one, but how are you gonna know how many bytes to jump?
what do you
Or
mean
are you
not
gonna
many
send this as
bytes to
well?
jump?
Yeah, because a single row in the disk, assuming that a row is a row in the
You're
text
gonna
editor.
slurp. So the process would be you slurp all the row, you modify the row, and then you send back the row.
Oh, so the client does the it creates the new updated row like if you change only one field doesn't matter. You're gonna the row that the payload that you're gonna create is gonna be the entire row.
Yes,
Ah.
that's what I said
Maybe
about
even a
Canteen just knowing its bytes, right? It doesn't care if it's like the size, whatever. It doesn't matter. It's all
Go,
just
Marin.
in a hash.
it could even be a bit more than just a single row, depending on how the chunking works out.
No, it can't be
Yeah.
more
It
than a single
can,
row because then my get a streak of having the index in there will fail.
uh, I mean, doesn't matter if you okay. It does matter. It only doesn't if you notify the server that it's a contiguous representation, right? This thing here is just to show that this is like this contiguous representation, right?
Mm-hmm.
That's all the
Yeah.
point.
Yeah. So I think I understand. I'm gonna try to explain it and you check if I got it, Mageta. So when you want to do an update as a client, you're gonna have to pick the data first that you want to update, maybe a few fields out of it. You change the fields, you create a new payload of the entire row, including the things that you didn't touch. You send that to the server node, to the bookkeeper node or whatever node, with an
Mhm.
index attached to it, and then we're gonna have a machinery that will discover, oh, this index is node D, so send this payload there, and then node D will overwrite the entire row with the
Yes,
payload that we just sent,
the entire record,
the
right?
entire record.
It doesn't know it's a row. It's just a record.
Yeah, yeah, sure, it's a record. So is that the way that you're thinking about this?
Yes, that's what I was thinking. And then the point that Marinho made about the Merkle tree, Marinho, if you can.
Yeah, because here, the way Mageta wrote the example, he's basically saying, okay, the first chunk uh, can be in either node B or node C, and there he wrote an X sign to mean this is a pointer, right?
Mm-hmm.
Um, but the way this will be represented, instead of having, okay, you probably still need a relation in the bookkeeper of
Uh,
which which nodes holds each chunk. You
yes,
do need
I was
that.
thinking of instead of pointing to the node, what about a pointer that is both the node, like something that maps to exactly this memory on the node,
Oh,
right?
so
Something
then
that,
we gain time, right? We don't gonna have to do the math again.
well, you do have to resolve, right? Because it's a fake pointer. It's a fake distributed pointer.
Mm-hmm.
It's just a thing saying, okay, go to, it's a mail address, literally. So yeah, deliver this letter to this guy here telling that I need his data. And then he goes to the post office, picks, stands on the line, and then sends over the package.
Mm-hmm. Mm-hmm.
Well, that was a needless explanation, but
Oh,
anyway,
that
you
was
got the
cool.
point.
Yeah, but the way I understand it, if this was implemented as a Merkle tree, instead of having basically you would have a list of hashes where each hash corresponds to a chunk of the
Exactly
overall
this guy,
file.
right?
Yeah, a hash of that guy, essentially.
So
And
instead of just
then
having node C, so one example here, instead of just having node C and node B, which are, by the way, I just noticed I did poo poo here because it shouldn't exist, right? Uh, so node B and C here.
Mm-hmm.
So they're the
yeah,
same,
instead you
right?
have
They would
yeah,
have kind of
instead
the same pointer, right, for this
yes,
record.
Ah. Well, but then the question is, if those guys are holding the same pointer pointing to where? Who is
So that's
having the
the
data?
hash of the tree, right? Because the Merkle tree, it holds the hash of the version of the data.
The
yes.
Merkle
So
tree
this
holds the
would be
hash of the
addressing
version.
yeah, instead of having a reference that says go look at node B, instead you actually have a hash of the actual contents of the thing that you are looking for.
Yeah.
And then the mapping of which nodes hold each hashes effectively would be a separate thing.
I don't understand. If we're gonna, instead of having pointers to nodes, we're gonna have a hash of the real data, why do you need to talk to somebody else?
That's kind of the point. You don't, because a hash can be computed by anyone.
So you don't need the. Uh, let's see.
Well, but in that case,
Yeah,
will the bookkeeper be holding actual data then?
No, it wouldn't. It's just the thing that does this one thing on entry point, right? That does computations. It can be anybody.
I think I'm confused. Marinho, could you check if I got it? So instead of having one, then a list of pointers node B and node C, we're gonna have hashes in there.
it would be a hash of the actual contents, yes.
So instead of having to go to node C and then going to index one and then getting the car one, we're gonna have a hash of car one in there.
Yeah,
Why do you need to go to node C then?
You need to
because
consult the data.
The node C has the actual data. You just have a hash of the data, which is kind of like a
It's
pointer.
Yeah, I think that's the part that I'm confused. What are we gonna do with this hash?
the hash is the access key of the tree.
So will
So
all
you
the
you
other
say
nodes be
search on the
holding
tree,
trees?
blah blah blah, this thing, and then the tree says, okay, node B.
Oh, so the Merkle tree lives in the bookkeeper.
Yes.
Ah, I see. So when
I
somebody
mean,
Actually, I
the
think
Merkle, like the
yeah, the
Merkle
Merkle tree
tree,
itself can
yeah. Go on, Marin.
yeah, the tree itself can be distributed because it's based on hashes and not actual pointers. It can live anywhere. It can even be spread out over multiple nodes.
Yes. But here's one thing I'm thinking now.
Okay, so my
Like,
understanding is go on, Magit.
I'm just thinking because you would either have two types of access, right? One is like a seek, where you know exactly where things are. So in our case, it would be like one, right? So I
Mm-hmm.
know it's one on this file. Get it for me.
Yes.
And then on that, we need to produce the hash,
Yes.
right? We need to know the hash. So we need some other persistent storage somewhere floating around. So that can't be fully derived because we don't have the data.
I don't know if I got that part.
For you to get the hash, you need to either have the data or to know where to get it, right? You need
Yes.
to have somebody persisting it.
Yes.
So, in the scenario where you know where to get the data, but you don't have it, you need to generate the hash somehow or to find it. In this case, the bookkeeper would have to have like one and then, okay, where is, what's the, let me look here for you, what's the hash for one? And then it goes there and says, okay, it's XYZ. And then it goes in the tree and then finds the node, you see?
Yes. But my understanding is that this list that you have in that example is doing exactly that. But instead of having node B and node C, those two things will be hashes that the bookkeeper looks to find which
Oh,
node it needs to
yes,
ask for.
it's analogous, but the thing is the tree versions the data.
Yeah,
The
because the tree is
tree.
built on the hash of the actual content. So if the content changes, that means the hash will change, which means the tree will change.
So the location in the disk will
Ah.
change, you see?
Oh, wait. I think I'm getting an epiphany here. So you're saying that when the data comes in, we're gonna hash
By
that
the
and
way,
use go.
just give me a sec. Let me commit this real quick to a branch because
Let
I'll
me
go have
guess.
dinner real quick.
Yeah. Let me guess on that. Uh, Marinho, my
I'll be
understanding,
right
Yeah.
back.
my understanding is the following. So when you receive the data, you apply a hash function on the data, and that will give
Yeah.
you a hash that you're gonna use to locate where the data actually is. Is that what you're talking
Yes,
about?
essentially. Because then when you go to look up, you say, okay, I want to read this file. I have the hash here.
Mm-hmm.
Though, does anyone in the system have a file with this hash? If so, give it to me.
So we're gonna index we're gonna hash indexes, right? Because I don't have the data, so I cannot hash what I don't have on hand.
You're not gonna you know how you you know how you have hyperlinks on documents and the
Mm-hmm.
link points to a location.
Yeah,
And um, you know how in Git you have the commit hash, right?
sure.
Uh, Basically, you take the concept of a hyperlink, which is a reference to something else, except instead of having a location, you just put the hash there. Like,
But I don't have
how
that.
can I say?
That's the problem. I don't have that
But why?
because I am a client and I only know that I want the records with the row ID one. That's the only thing that I know.
You want the record with the row ID one, and that's the only thing that you know.
Yeah. So my understanding, based on what Magetta was describing, is that there was a number before which the number one and then a list, number two, then a list. Those numbers are the row IDs, and the things on the brackets that those were nodes that I can find the data that I'm looking for.
Uh, yes, that is correct.
So then, where does the hashing comes into play?
The hashing comes into play where basically it allows you to separate the structure of the data from where the data actually lives.
The structure of the data. The
Yes, because
structure
in
of
the
the data.
example that in the example that Magetta wrote, he basically says the bookkeeper has okay, the bookkeeper knows that there's a file named cars.ndf,
Yes.
and this file is split into chunks, which in this case they are actual rows in the database, but Canteen doesn't care about that.
Yes.
And and it knows that chunks 1 and 2 can be retrieved from nodes B and C, and then the chunk 3 can be retrieved from node A, and so on, right?
Yes, yes, yes. So far, so good.
This means that the structure of the data and the location of the data are kind of mixed together, right? Because you have a list where you say, okay, this file here, this chunk of the file can be found in these nodes, and this other chunk can be found in that node. The
Yes.
structure of the file, uh, but if you replace, but you can actually replace the nodes with actually hashes of the contents of the file, and instead you can say, okay, this file here is made up of these chunks. Here are the hashes of the chunks in sequence, and then separately you say, okay, I know that this hash, there's a copy of it in node A, and this other hash, there's a copy of it in nodes B and C. And this way, the way that the data is assembled or built up, it doesn't actually depend on the locations of anything. You can have that separately.
Okay, I think I had a different understanding. Let me try to explain and then you confirm. So my understanding is that is uh, instead of having a map from indexes or keys to locations, we're gonna just have a sequence of hashes, and that using those hashes in the tree will give us the location later on.
Yes.
So let's imagine that the sequence of hashes could be an array, and the row ID of the
Yeah.
client is how you're gonna index that array. So if I want
Essentially, yes.
the row 3, I'm going to go to my array of hashes as a bookkeeper, and I'm going to index 3 in that array. That will give me a hash that I will use to find where this is.
Yes.
Okay, that is progress. Now the question. The bookkeeper doesn't know the data at all. So how is it going to know how to hash it?
Um, it doesn't have to actually.
No, you said that the hash is based on the contents of the data.
Yes.
So if I don't have the data, how am I going to apply the hash function? Because I need to construct my array of
This
hashes, right?
Well, the storage node would apply the hash function because it does have the actual data, right?
Well, theoretically speaking, the bookkeeper has a moment in which it knows the data because it is the first one to receive the payload, right?
Well, yes.
I think that's
It could
bad
hash the
because
data.
the hash should only be added to the array when you know the persistent occurred correctly. So I think we should make the bookkeeper await for the acknowledge of the storage node that it did in fact persisted, and then the storage node can return the data, and then the bookkeeper grabs the data, hash it, and put it in the array.
Yeah, it doesn't actually need to return the data. It can just return the actual hash.
Sure, you can return the hash directly as well. So I have a question now, another question. I don't know Merkle trees yet,
Yes.
but as far as I can tell, you said that you can use the hash to traverse the tree and find the location, right?
Right.
Why does the hash need to be related to the data at all if we only care about locations?
Uh, because if it isn't, then that means you now need to have an authority to actually issue the well, it's no longer a hash anymore because it's not related to the actual contents. But then you need an actual central authority that will say, okay, this chunk here has this row here or whatever has ID 0 and this one has ID 1 and so on.
Ah,
And
so instead
now
of having a third
and
party,
now
we can discover ourselves.
yes, because with a hash, if you have the contents, you know the hash, right? You can just compute it. But if you don't use hashes, then you need some kind of central authority to issue numbers that you can use to differentiate between the different rows, right?
Ah, okay. We are almost done. My next question, and maybe next final question, is what is up with this tree and versioning of the data that Magetta talked mentioned?
Well, because the way this tree is built is that, okay, you have the hashes of the rows, right?
Yes.
And then instead of just having a flat array, instead you have uh, you have it broken up into nodes, right? So it's an actual tree instead of just a list. Um, but then each node refers to the hashes of some number. Let's just say two, make it a binary tree because it's simpler. But it could be a B tree, so it could be larger. But the tree will have the hashes, or the first level of the tree, the one closest to the leaves, will have the hashes of some number of two rows, right? And then
Yes.
you take a hash of the node itself, use it as a reference to build the next layer of nodes,
Wait,
which
can you repeat the last part?
yeah, so you take the hashes of the rows and you put
Yes.
them in a node.
Yes.
Then you take the hash of the node
Which I don't doesn't know I don't
and
know what that
you
means, but yes.
oh, the node itself will be just data, right? So you
Yeah.
can hash it theoretically.
Well,
So you take the
it's
hash
not
of
only
the
data, it's a
node.
hash. I'm gonna hash the hash.
Oh, it's not just a single hash; it's a pair of hashes, right? Because we're building up a binary tree.
Wait, what? No. My understanding is that if you have a binary tree, you have a node that creates two other nodes.
Yes.
So a node doesn't contain a pair
Well,
of
okay.
hashes.
No, let me give you a concrete example, okay? Let's say you have a file and it has 8 rows, right?
Sure.
So you take the first 2 rows, you hash each of them, and now you have 2 hashes, right?
Yes.
So you put those 2 hashes together, and that's the nodes containing those 2 files.
Oh, that's the
Okay,
parent
just the
then?
concatenation. No, no, yeah, that's the parent of those 2 leaves. Yes.
Ah, I see. Now I
Then
understand.
you do this. Yeah, yeah. Then you do the same thing with the other 6 rows that make up this record, right? This
Yes.
file or whatever. Which means now instead of having a list of 8 rows, you now have 4 nodes of a binary tree, each one pointing to 2 rows. Then you
Yes.
take those 4 nodes, you split them into pairs. The first pair, you hash each of them, and you concatenate the hashes, and that's the parents of those 2 nodes.
Yeah, yeah, yeah,
And
yeah.
you do the same with the other 2, and then you keep doing that until you have just a single node at the top.
Ah, okay. So we create bottom to top, then the tree.
Yeah. Yes.
Ah. Okay.
You
Is there
have to
any?
do this bottom up. Yeah, you have to do this bottom up because the tree is built from the hashes, and the hash ultimately comes from the content that you're storing. So you have to start with the content and build it
Yeah,
upwards.
yeah, yeah. That makes total sense. But my question is, what about removing stuff?
Well,
Is that like that sounds
do
like a
you know?
pain then?
No, it's just path copying.
Path copying. Hmm. Continue.
Yes. Basically, if you want to edit a tree, you don't need to change the entire tree. You just have to change the path down the tree to the portion that you were trying to change.
Um, but but the let's suppose that you said eight, right? So we have eight leaves, right? And
Yeah.
we're gonna have many parent. No, not many parents. Like what? Three or four parent, three levels or something like that.
Yeah, one level will have four nodes, and then two, and then one.
Yeah. So all of the leaves participated in the creation of all the parents. Agree? Well, not
Uh,
all of them necessarily because you have the subtrees,
no,
right?
just the root.
Just the root, yeah.
Just the root.
Yeah. No,
Just
well,
the
not only
root.
the root, but your subtree.
Yeah,
Uh,
though. So suppose you want to change the very first record, the one at index 0, because we're not savages here. That counts for one. Um, so the way you do that is you say, okay, obviously the root is gonna change, right?
Now, a lot of
So
guys are
we
gonna
have to
change.
rebuild that. No, no, no. The root is gonna change, obviously, because it depends on the left child, which is where the
The
row
zero
0 is going
is,
to be updated.
yeah. The
So
parents,
you
the
go down
grandparents,
to
and the root will have to change.
yes. So you change the row 0. You still have the hash of the row 1, so you can just reuse that
Yeah,
probably.
yeah.
But you build up a new parent of the nodes of the row 0 and 1.
Yes.
And then you build up a new grandparent for that, and you do that all the way to the root,
So
and you
it is
don't
a
have to
hassle
touch
then.
the rest of the.
It is a hassle then.
No, you don't have to touch the rest of the tree. Is the point?
No, no, yeah, I understand that. But if you have like 50 levels, right? You're
Do
gonna
you
have
have
to.
any idea how much data you need to have a 50 level tree if you do well? If it's just a binary tree, it's still a lot though. It's like 2 to the power of 50. Do you realize how much data you need to have 50 levels in a binary tree?
Again, that's my point is that if you want to change anything on the leaves, you're gonna have to propagate that all the way to the root.
Yes, and this is logarithmic on the size of the data.
I agree on that, but that sounds like because you need to think about this, Marinho, because we're gonna have to decide now that we're coming up with the proper design, right? So we are establishing what the payload is gonna look like. We're establishing how we're gonna separate differentiate one node from the other. We need to start thinking on how we're going to implement all this crap. So the first thing that came to my mind is, are we going to implement Merkle trees ourselves?
They're not conceptually difficult to implement. It's just you have to be careful because you're dealing with cryptography, right?
I don't think you are
I'm back.
you're having the same perspective that I am, because from my point of view, if you're not dealing with like imperative language with pointers, this is going to be a ton crap of work though.
No, it's not.
It sounds like it. Really sounds
Copying?
like it.
Copying? I don't think it is.
No, yeah, we're gonna have to
Yeah, let
trade.
me.
We're gonna have to or do copying and being really inefficient about it,
Oh, but
or
since we have to use
No,
like SHA or something, I think it's better to do it in C. Man, it's just a normal tree with how can I say? Just a normal tree, but instead of
mm,
having like we have a list, right, of nodes, like it's not a binary tree or something.
yeah.
yeah, binary
Because
tree is kind of a hassle. It's better to do
yeah,
something a bit wider than that.
Okay,
yeah,
so
because you can check out to a specific hash, right, and
yeah.
then from that onwards you can
Okay,
expand
so Magenta, I'm gonna
stuff.
explain to you what Marinho explained to me while you having dinner. So Marinho explained to me that instead of having a map from a row ID to a list of pointers, which would be the locations, we can just have an array of hashes, and the index that the client will ask will be the index of the array, which will be a hash in the Merkle tree that will give us the location.
Wait. I got lost. Say it
Yeah,
again.
that's a lot.
Yeah,
Start
no,
from the
you
beginning.
you you skip you skipped way too many steps, Lemos.
Okay. Okay. So, do you remember? Can you share Emacs again?
I can.
Yeah, that will help. Okay, let
Okay.
me look at that here. Okay. So you see the bookkeeper in the cars.ndf entry, you have like a map, right? Which is a number to a list, right?
Mm-hmm.
So what my Marinho was explaining to me is that the bookkeeper will actually have an array of hashes, an array of hashes.
You right.
And
Okay.
then when the client says, "Give me the first," or "Give me slash update the first, the one with the number one," right? We're gonna use that number as an index into this array of hashes. So we're gonna
Right,
retrieve,
because every guy. Okay, so that would be a hash for this, a hash for this, a hash for
yeah,
this. That
Yeah,
would be the same
Yeah,
as
yeah.
this, I
yeah,
suppose,
yeah. So
and a
then
hash for this.
we would use that
And they're
hash.
all organized in sequence here. So
Yeah,
one would be hash for this guy,
yeah,
two would be the hash for this guy, and so on.
yes, exactly. So then we would look up on the array, grab the hash, and use that with the Merkle tree to discover which nodes have that information.
Which nodes have that
Uh,
information?
That's the way that I
yeah,
understood.
that's not quite right because you see, because the hash is derived from the actual data, right? You
Mhm.
can just ask all the nodes, "Hey guys, I have a hash here. Does one of you have the actual file that corresponds to this hash?" And then they can say, "Yes, I do," or "No, I don't," right?
Hmm.
Oh, so when
And
you
then,
retrieve the hash, you do broadcasting.
well, not necessarily. You can do this like incrementally. The bookkeeper could just do this as data enters the system, and it can keep internally a mapping of which nodes say that they have which hash, essentially. Um,
Or as soon as another node adds data to itself, it notifies the bookkeeper, right? Saying, "Hey, I have this
yes,
now."
yes, yes, yes,
Yeah,
exactly.
yeah. Okay, so
Uh,
now my question
what
is, the lookup in the Merkle tree represents what now then?
the Merkle tree represents the actual structure of the file, or well, not really a file, the higher level structure, because suppose that you want to suppose that you want to update one of the rows, right?
Yeah.
Yeah. Uh, if you want to update a row, uh, if you just operate on like single file, the entire file has a hash, and you just use that. Um, you have to update the entire thing and hash the entire thing, and that's
That sucks.
probably not a good idea in a distributed context, right?
Yeah.
So instead we say, okay, a file is really just a list of chunks, and we can decide the size of those chunks. Here we can just say they are rows because that's the example Magetta went with. So it's a list of rows, effectively. And
Sure.
each row we know has a size,
Hmm.
and the size of the file is just the
Well,
sum of
Canteen
however
doesn't
many
know any of
rows.
that shit actually.
Oh, we can.
Yeah,
Just doesn't matter.
No, no,
yeah.
no,
The
no. All
point
the
is the
math
file
needs
is
to go on the client, Magita. Otherwise, we're gonna leak stuff.
no. The point,
No, but
don't
that's
worry
not.
too much about the point here. The point here is that the file is not a monolith. It's a list of chunks.
Sure.
Okay.
Yeah.
And each of those chunks has a hash, right?
Sure.
Hmm.
So if
Oh,
you have the hashes of each chunk, you can look up the entire file. Uh, but that's annoying because then you need to have a number of hash viable. So what you do instead is you say, okay, let's collect those chunks into groups of 2 or 4 or 8 or whatever size you find more convenient. Each of those groups itself will become a separate file representing a node in a tree,
So
and
you
it will
have an
just contain
intermediary
the
file that contains all the minimal chunks.
yes, it will just contain the hashes of the leaves, um,
Hmm.
and then that becomes a node in the tree. And
yeah. I
then
completely didn't get
if
any of
the
that before, Marin.
Like,
yeah,
do you
and
agree that
then
storing the hash for every individual row that you write, every data you write to a virtual file, it's a pain because you're gonna have basically one hash. Like you write the letter A, let's say, and then you produce a 64-bit hash. Like
Fine.
that's big.
Fine.
64, yeah. So, but in some other cases that's fine because you might write a lot, right? So it will depend. But the better approach here would be to have intermediary virtual files where you agglutinate all of these other hashes with one hash. So you would say these cars and df you are dividing in, I don't know, 128 kilobytes each, and then you know that dividing these hashes you have, like, doesn't need to be by size, but we're dividing like 128 hashes inside of this file,
Mhm.
and then 128 on the next file, and then you just reduce the overall set. You still have to go through all of them to get all the data, but you just go by sections of it instead.
Wait,
which is much
so are we
better.
Yes.
just using the hashing just to do the searching faster?
I
No,
wouldn't say
we're building a
faster.
tree. We're building Yeah, we're
Yeah,
building a tree to do the
we're
search
building the
faster. The
structure
hashes
out
are
of
just
this.
how we build the tree because we don't have pointers because this is
Mhm.
distributed.
No, 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 no. The part of no pointers and hashes, I got it. Because we need that because of the central authority problem that you mentioned before, Marin. That's fine.
Yeah.
I'm trying to understand what are we gaining by doing a search with the hashes. That's what I'm trying to understand right now. And the way that Magetta said that we're gonna be combining virtual files until we reach the root of the Merkle tree, it sounds to me that we are gonna use this to jump the tree to have more performance.
Well, yeah, because here's the thing: if you have a file with 100,000 rows, it would be kind of a hassle to have to deal with 100,000 hashes to look up the file, right?
Yes.
So if we chunk those files into like smaller sections and we build a list of nodes of intermediary nodes, and then we chunk those intermediary nodes to build another layer of intermediary nodes that's even smaller, and we keep doing that until we have just one node. Now we just have one hash for the entire file.
Yes. Okay. Okay. So Magetta, do you think we can make an example instead of having exactly as you did with cars in there, but using some sort of like pseudo hashes in there?
Let's try. So, okay, so I'll I'll override this, okay?
Sure.
So we have four nodes in this example.
Yeah.
So what do you want here?
I want to do the same example. I want to do an update.
Okay, so let's no, but I mean, let's change the data, right?
Ah.
What do you want me to change?
No, the data can keep the same. It's fine.
Okay, so you want to update with this example of now.
Yeah.
Okay, so let's update this, I guess, right?
Yeah, that's the thing that it needs to change to the hashy thing.
So we're gonna have something like a let me see. So we need to get from this guy a hash, and then from this hash we need to this we search on the tree, and then this gives us the the actual data. So far, that's what you guys are thinking. Is that correct?
No, that's the thing that I want to Marin to explain because as far as I can tell, we what should happen is that we need to find where the data actually is. That's what I'm understanding. And the Merkle tree will give us that
Yeah,
information somehow.
it gives you the
The,
specific hash. Like given a hash, it can provide you with the specific data that is scattered over whatever. So it will be probably not the data, but a pointer, right? Just somewhere where we can get it.
yes, it's
Oh,
more of a
so
pointer.
okay, so here's my question. So when you do the here we're gonna have a bunch of hashes, right? This cars.ndf, we're gonna have a bunch of crap in there.
Hmm.
We're gonna use
Yeah.
that to look up in a Merkle tree, right?
So it
The
the way I'm thinking here, like we still don't have the hash at this point.
Okay, we don't
So
have the
what we need
hash.
to do is, you know that cars would be record one. So what's the first chunk of it? So let me do the example with without the chunks, and then we abstract to the chunks.
Let's do the
So
following
you would
actually. Let's
have.
assume that all the nodes are empty, and let's do an example of doing an insert. I think that's much better.
I'll put like this. Okay, I'll do like this. I think it will be easier.
Oh, but in here we
It will
already have
be.
the data, Magita.
No, I know, man. I just wanna do it as if it's like bytes. You see, so not to mean it's just as sections on the disk. It doesn't matter.
Sure.
So this, and I'll put four, and then I'll put car four. So there we go. So that's our data scattered, and if we know that basically the order is this. right? So this two, this two here. So what's the organization here? What do you have in mind, Lemus? Explain
Uh,
to me.
okay, so let's suppose that I want to insert something into the cars table, right?
Mm-hmm.
I am Racket Tower, I am Perplex, I am Postgres, doesn't matter. And I want to insert a new entry of a car 5, right? So let's
Mm-hmm.
suppose that we only have two columns for now, the year and the name. Cars 5 2002. I talk to the bookkeeper and I'm gonna ask it using that payload up there. That I'm gonna ask it to insert that. Right? Is that reasonable?
Yeah.
So what should happen? Step by step.
So the first step would be it goes to the bookkeeper, gets the response, and then it says, okay, I have something to write. So let me separate a random node, give him some random policy to write this thing monotonically increasing. So it will go here and let's say it chose node B.
Sure.
And then it wrote here 5, car 5. Oops. Now the now the car is here. So and then it needs to update on the global record keeping. It needs to say, okay, I have this new record stored and it's mapped to this specific location. So we have the hash of this guy.
Wait. Stop right there. Marinho proposed that the storage nodes will return to the bookkeeper the output of the hashing function.
Okay, that works
That's
too.
just Yeah, that's just so the bookkeeper doesn't have to actually hash the data
Yeah,
itself,
like I
or
was
the
thinking
data
of
doesn't have to
each
pass
doing it,
through.
but it doesn't matter. Like it
Yeah,
can distribute the work, right? It could be a heavy file, let's say, and then it sends back, right? That
Yes, so
sounds
we're
more
gonna
reasonable.
receive the 500 there, right?
So you receive this
yeah.
guy, and
Yeah.
then you say, okay, 0x500 node B. It's my funny pointer. Node B, and then position of the list. I don't know. Node B2. Okay, I'll start with 0. Okay, not
What is
counting
the
one.
position of the list?
What's the
Oh,
position
oh,
of the
oh.
list?
Oh, okay. No, it's because
Let me
this is just
do
for
another
indexing
syntax,
later. Okay, that's fine.
like an Erlang map.
Okay.
So it now has a pointer saying, okay, I have this data here. It's on node B, this position here on this list.
Yeah,
Oh,
that's
okay.
not.
Go, Marinho.
Yeah, that's not quite right because you have a hash and you know that the hash is in node B. That's kind of entangled with the actual structure of the
Yes,
cars file in
yeah,
the.
we're not using the tree at all on this, right? This is just a
Yeah,
dumb map.
right.
Yeah, yeah. Let's go baby steps. So now, next process. It was wrong. Car 5 is not 2002 at all. It is 2003. So I need to do an update now. Okay.
Okay. So
So
you would come here,
sure.
and then the bookkeeper says, "Okay, uh, you have the old hash, right? Because you had to read the
Yeah,
data.
but
So you had
me as a client, I don't know at all, right?
you
I
do because you had to read it. So when we respond with the data payload for you, we're gonna respond the chunks with this identification.
so we will leak the hash to the client.
Well, I
Not
don't see any
really
way
leaking
around
it.
it. When you're gonna write something to the disk, you need to know where to write. There's no magic.
Marinho, do you agree with Magenta
Yeah,
said?
yes, I do. Either
So
you need to do
then
this location.
that's the answer to my problem that I am having for 1 hour already. So there is a need. It cannot be 100% magical from the client's perspective. It needs to leak stuff.
Yes, which is analogous to what a POSIX does. It doesn't change.
No, but that
It
was
just
my
leaks
question
something
all
else.
along, Magita, because I was confused on what was the trick that Merkle trees have that would allow us to not leak that. But the
There is
answer
no
is that
trick.
it
You'd have
doesn't.
to have a. You would need to have a separate layer to map hashes to names.
Yes.
Ah, okay. So we're gonna return the 500 to the client. So the client would have to store that shit.
The only case where the Merkle tree is magical, maybe not even that. Like the only case where it would work in this case would be when you say cars NDF, like file name. Sorry. And then you say, I want to read this guy here, and then it's like the data for car 4. And then when you produce the hash, it will be exactly this hash. And then you know where to access, right? Because it's the same data, it's already there.
Mm-hmm.
So you can compute the hash and know where to get by the pointer. So you search on the Merkle tree, and then it says, okay, here is the pointer. Go there. And then you go
No,
node
no, no,
4.
but that's
Node B.
fundamentally what your Erlang map is doing right now, right?
Yes.
Yeah.
Which would this Erlang mappy thingy could be the Merkle tree.
Yeah,
That's what
yeah.
I'm saying.
That I understood. That is perfectly logical to me. My problem all along was that how are we gonna map
This
stuff
is
from
yeah, this is
my Geta QL to this nonsense here?
yeah,
And
this
the
is
answer is
not
that we
quite
don't.
the
The
Merkle
client
tree.
needs to know.
Gomani, what is it?
Yeah, this is not quite the Merkle tree. It's just the backing storage for it. So like you have the leaves, right, which represents chunks of a file essentially. And then each leaf has a hash, and then you can use the hash to, in this case, you're using the hash to actually index it into actual physical storage, right? Um, the
Yeah.
Merkle tree itself would be built on top of that as a way to like aggregate the chunks into a single logical file.
Yes. Yes.
Yes, yes, yes. But that's aside from what the thing that I wanted to understand. What I wanted to understand
They would
is that how are we gonna retrieve as a bookkeeper the five? How are we gonna map the update whatever where name equals to car one? How are we gonna map that to 500? And the answer is that we don't. The 500 needs to come in the payload as well.
the find one needs to come in the payload.
Yeah. So
I
now I think I don't have any problems because that was my entire issue. Okay, so let's go back to the payload because I think we are missing some fields in there. We need file name, but we need to pass extra data when doing updates, right?
uh it would be something like this. Uh
I'll be right back.
Something like this. It could be bytes.
Instead of key, just put hash. I think it's much more readable.
Well, it is a key.
Sure, I understand. But to me, I need to put in my mind we are dealing with hashes, Merkle tree, hashes, Merkle tree. Okay. Uh,
You also would want this on the read too.
yes, yes. And the append, Canteen can do the stuff automatically, right? Automatically
Yeah.
increasing and stuff like monotonically increasing.
Mm-hmm.
Okay. So is that it for writing? Are we done? What else do we
One
need?
thing here. Let me think. So the case where I mentioned the magical part, where you don't need to specify, is if you already have the data.
Yes.
But then at that point, like that's useless, right? Because you already have it. Like, why would you
Yeah, yeah.
want?
Why would you
Yeah,
want to read it if you already have it?
I don't know. You just want caching. I don't know.
Caching. Let's see.
Okay, so that's it. And then the tree does this is a leaf node inside of the tree, and then the tree agglutinates the entire scope of these cars and the F. Oops,
Yeah,
these
yeah,
cars and
yeah.
the
That's the
F.
way that I understood. But Marin was talking about something different because he said that the Merkle tree will come on top of these hashes, right? That's what he
Yes,
said.
it is making the representation for the file changing, because the hash would be the agglutination of all the other hashes that
Yes,
are
yes,
inside of
yes.
it. Yeah.
That's the way that I understood. So from this section of writing alone, I think we have already two to-dos. We need to do bindings from SML to for hashing functions, and we need to do bindings from Merkle trees implementations.
Well, we let me think here. Say it again. The two.
At least two to-dos. We need to make bindings from SML to SML from C hashing functions libraries, and we should also make bindings for SML manipulating Merkle trees.
I think we should start by writing the Merkle tree. Like, here's the thing: the Merkle tree can wait. We can do a crappy design with a map on the beginning, just to get going with SML, and then we do the interop with C. What about that?
But we need a C anyway because we don't have hashing functions in SML. How are we going to get
Yeah,
the
but that's
500?
simpler than making a Merkle tree.
No, I'm not proposing us to make anything. I'm proposing for us to steal things from making bindings.
Ah, man, I prefer to just do it.
Really?
It's not that hard. Like, well, hash function, we're certainly gonna use it from somewhere, but some
Exactly.
C library.
Exactly.
But the Merkle tree, I prefer to do it myself. I hate picking these random structures from people.
Okay, so we're gonna implement the. Let's put the two to dos in there. So make bindings for hashing and implement Merkle trees.
So let me remove the
No, we're gonna
this
talk
here.
about reading as well because maybe that's we're
No,
gonna.
it is. We already did. It's already on here, right? So I thought we were just gonna talk about write, but we did on both.
No, okay.
The data. There's some problem with me typing today. Don't know what it is. Uh,
So another thing, the payload that we described is gonna be the payload between a bookkeeper and a client. What about the payload between nodes, between server nodes, Canteen nodes? How are they gonna broadcast the stuff? Shouldn't we talk about that?
just a sec. Let me just write so I don't forget. So I already
Bindings
did
for hashing functions,
bindings for hashing for hash functions.
and the other one is implement a Merkle tree.
Implement a Merkle tree. Miracle tree. And the other thing we need to do is basic design of bookkeeper. So in the future, we could even do reft, like implement or get from somewhere else. Reft, and then this thing here with the Merkle tree could be floating around across the entire mesh.
Sure.
So it's not centralized in one or two or three bookkeepers.
I was thinking
So
every storage node should be a bookkeeper.
then we need to synchronize, right? Which is a problem. I mean, we can have something like called flush, like a command, like literally like POSIX, like flush, and then it forces
Oh,
to synchronize everything.
wait. Your idea is to make it centralized first with a single bookkeeper so then we can focus on the Merkle tree
Yeah,
first,
just
and
yeah,
then
exactly.
we spread the
And then
thing
we
out.
exactly then we segregate,
That's
we
smart.
spread the Merkle tree. So basic design of with a single bookkeeper.
Bookkeeper.
Uh, basic design with multiple data nodes. And the last one
Is
is
having multiple bookkeepers.
keepers with
Wait,
raft
so you want to make a
with
basic
flush.
design with multiple data nodes. Aren't we going to start with multiple data nodes?
Yes, that's the point.
Okay, so I have a question. Shouldn't we also design right now what is the payload between a bookkeeper and a data node?
I mean, that's an implementation detail. I don't think it
But we
matters.
are talking about implementation details. The thing that you did up there is a JSON, literally.
Like, wait, repeat the question. Then I didn't get it.
I think we should discuss because we did the payload that we made up there is a payload between a client and a bookkeeper.
Right.
I think we should also define what is the structure of the payload description between a bookkeeper and a data
No,
node.
I don't know what that will be. Like, I'll just know that when we start doing the the data nodes. I don't know the needs of the
It
communication.
needs to have at least a field for the hash because that's what the bookkeeper will ask for, right?
Okay, if you want to add, let's do. So type, let's do types here. So I'll do F sharp E.
We are
Type,
going from like an enum that seems like Rust to like F sharp.
And
okay.
I'm back.
Hello.
Here I am, rocking
Here
like a
you are.
hurricane.
Is that a TV trope?
No,
Don't
that's
know.
a song. Ah,
That's a song.
yeah,
Okay, so type, this would be bookkeeper request.
yeah.
and
We are
then you're gonna
defining
have
Marinho
another.
right now. What should be the payload between a data node and the bookkeeper? Data node request.
Um,
So file that you want inside of it. Well,
Yes.
actually, not even that matters.
Are you sure? Shouldn't a node be able to contain many files?
Let me see, because I think the file name should be contained on the hash too, right? When you produce the hash, like it should take into account all of
Ah.
this.
Well, if that's the case, screw the hash. Screw the file name, sorry. Just put the hash.
So
yes,
this,
at the level of the data node, you really only care about the hash, I guess.
Do we need anything else?
well, pass depending on the operation, you need to pass the data,
Yeah,
right?
that's true. I think that's it, actually.
So
Yeah,
let's
you
review
either
the
pass the
features.
hash if you're yeah, you either pass the hash if you are reading, or you pass a data payload if you're writing, and then you don't actually need to pass the hash when you write
Because
because
the data node can hash itself.
yes,
Yeah.
Cool.
So I will make Jira tickets for this for us.
Let's make GitHub issues,
So
though.
it's literally gonna become management culture here.
Yeah, but this level of management is
I
fine.
need KPIs, guys. I need KPIs. Bindings for hash functions. So we need to do binding for C. I mean, it doesn't need to be C. It could be something else. But
um, what other language SML does FFI with?
well, I meant like it could be a microservice, right? That you communicate and it gives
Not
you a
at all.
hash,
Not at all.
like TCP.
Wait, are you literally considering like, or no? You must be trolling. You
Yeah,
must be joking.
that's not a microservice, right? That's a pickle service in this case,
It could be a server node that you
or
do HTTP
pickle
request to
services.
receive.
So either option works.
No, we are not doing that. We
Man,
are
I,
not doing
I
that.
I thought this. I said this joking, right? I was joking with Benny. Oh man, like people soon will invent something like pickle services or something that you need to divide, and then the
Let's
code is
make the
just like
patent right
literally,
now.
and then the code is literally just one single function running around. And
Man,
then I
Marinho,
literally googled that, and that was pickle services. I
remember
invented
Jian's
it.
presentation yesterday where he started talking about dependency management and I immediately pointed out of the npm package that does the odd or even evaluation? That
wow.
can be a pickle service, man. A service that you ask for answering if a number is odd or even.
Pickle
Imagine.
That
services.
already exists. It already exists. It's called AWS Lambda.
Yeah, it's an we joke because there's this developer advocate, right, which is just this Japanese girl that keeps publishing anime for developers, like just saying Azure function, like and making things on Azure function. Yeah, sure.
Okay, we're not doing pickle
Wow.
services though. Definitely not.
Why not?
Because
What do you have
because you're
against
this
it?
is like for real though. This is very extra
Oh, look
complexity
at
for
this.
no
There's
reason.
an example made in JavaScript full of emojis. Like, just look. Doesn't this look pleasing to the eye? Where
Uh,
pickle services, where the overhead of the network is greater than the overhead of your program. So you blame the network, not the programmer. Does that make sense?
okay, so here's the
Okay,
thing.
so
I have my doubts about how easy it is to implement a Merkle tree.
man, it's just like a trade where instead of having how can I say,
It's
instead of
literally just a tree. Just replace pointers with hashes, and you're done.
yes, and they will have lists, right? Instead of like think of a binary tree, but instead of the binary tree, it just has a bunch of lists inside of it,
So like,
arbitrary.
so like a B plus tree.
Kind of, because there's no splitting, right? So it's actually easier.
Oh yeah, no, B plus tree would be okay. So
Hellish.
we need to find a C header, ideally header only library.
Man, I can start the Merkle tree today if I have the imagination to do that.
So
I
let's
just
go.
want to do the microservice. Let me just do the Dreamcast thingy because I just want. I'm excited to see if that will work. And, So
Okay, so
okay,
but okay, so after this commit we are done, and I'm gonna finish the recording. HTTP Pico servers. Hilarious.
okay, there we go.
So I'm gonna finish the recording now.